So we know that when a current carrying conductor is put on a permanent magnet, so they will produce a caterpillar field which will have a forces that acted on a current carrying conductor. So this direction of force can be determined by using the Fleming left-hand rules. So how do we determine the direction of force by using the Fleming left-hand rules? So first, we have to know that each fingers represent which quantities. So for this term, is represented by the direction of force. So means that where the direction of your thumb pointed will be the direction of your force. This one will show you the direction of your magnetic field strength. Means that the direction of your permanent magnet, which is pointed from the north pole to the south pole. So which is denoted as a B, symbol B. Well, this one is the direction of your current flowing. Means it is the current direction that flow through the conductor. Okay, now I have a few examples to show you how to determine the direction of force. So I just use the symbol to represent it. So B is the direction of your magnetic field, which is from from north pole to south pole. Well, this one is the direction of your current flow through your conductor. So now you have B pointed downward. So B is the magnetic field strength, so which is directed downwards. Okay, so this finger you point down and you will get, okay, remember, open like this, okay, because your eye is at that direction, so you know that your current will be, okay, see, this one is pointed for your B, okay, direction of the B. So this is the current flow through it. So this direction of the thumb is pointed inwards. Thus, your force is pointed inwards. Okay, I just draw it here. So this show you the force is pointed inward. Means that your conductor will move downwards. Okay. Now, for this one. Okay. For this one, how do you determine? So this is your direction of your B. So B is pointed out downward, and this is your eye. So this eye is showing to the left, so your thumb showing it outwards. This show outwards. Means that your force is directed outward from the page. So this one is inward to the page. So the current conductor, which the conductor will be moving up like this, will be moving out. So for this one, the current conductor will be moving down, okay. For this one, okay, your B is pointed here and your eye is pointed here, okay. So it means that your force is pointed outwards, still pointed outwards. So this show out. So this is your F. So it means that if this is your current conductor which pointed here, this is your current which flow through in this direction, and your B is in this direction. So your F is pointed out. So your current will move like this due to the force acting on it. For this one, okay, so B is in this direction and I is downwards. B is in this direction, B is in this direction, and your eye is in this way. So your F is pointed inwards. Your F is pointed inwards. Thus, the current conductor will move into the page, Or other words, we say that current conductor will move like this. Because of the acting force is pointed inward, means you are actually pull, like there is a force that like this. Okay? Act on it. Okay, now for this one. So let this one as a inwards current. The direction of the current is flowing in means, let's say this one is your current carrying conductor, so your current is flowing inside here. So if the current is flowing inside here, this is your direction of your magnetic field. So inside here, this pointed I is pointed inside, and this is your direction of B. So you know that the direction of your F will be in this way, downwards. So it will be pointed here. Yeah, I repeat, inwards for I, B is in this direction, thus F is here. So your F will be here. Okay, so means that when you have current carrying conductor in this direction, so it will move in like this. It will move like this due to the force that pulling it down like this. Okay? Or this one. For this one, so the current carrying conductor is inwards and B is upwards. So you know that the F is pointed to the right. The F is pointed to the right. So it means that your F is in this direction. So means that this current carrying conductor will move like this. Okay? Well, this one, okay, current is pointed into the page and at B is in this direction. So your F will be pointed up here. So it will be showing here, F. Okay, for this one, your I is inwards, B is downward. So your F will be in this direction. Remember, it's 90 degrees to each other. So your F will be in this direction. So it means that if this is a current carrying conductor, because of the F is acting in this direction, your current carrying conductor will be moved to here. Okay. Well, this. So this one represents that the current carrying conductor has the current that flowing out the page. So out the page, something like this, out the page, and B is pointing to the right. So out the page, so this one showing the current flowing out the page, and B is in this direction, so your F will be upwards. So your F will be upwards. Okay? Now for this one, I is still up, B is upwards, I is up, B is upwards, so your F is pointed to the left. So for this one, your B is inwards. Your B is inwards. So B is inwards, so we are using this one pointed in, and I is in this direction. Your I is pointed to this direction. So if you look carefully, your thumb is pointed here. So your thumb is pointed here. Okay? See? Thumb is pointed here. Okay? So it means that your F is pointed downwards here. So your current carrying conductor will move to here. For this one, B is inwards, B is still inward, I is upwards, I is upwards. So your F will be pointed to the left. So can you follow what I have taught you? So if you have any question, you just draw a bit of your direction like this, 90 degrees to each other, and try it more times.